Now let's discuss conic sections. A conic section is a curve formed by the intersection of a plane and a double cone. So under conic sections, we have the circles, the ellipses, the parabolas, and hyperbolas. Now let's discuss circles first. So circles, in circles, the set of all points are of the same distance from the center. Say for example, this is our circle here, and this is the center of our circle. So the distance from this point, from the center to any point on the circle, is called the radius. And this one is our center and has a coordinate, which is HK, or point HK. The standard equation for circles is just x minus h squared plus y minus k squared equals r squared, where HK is our center. Say for example, we're given this problem: x minus 2 squared plus y plus 8 squared equals 81. Okay, the center here, okay, HK is just positive 2, negative 8. So 2, negative 8, and our radius is just the square root of 81. So r is just the square root of 81, because 81 here is equal to r squared. So this is just equal to 9. So this is our h, this is our k, and this one is our r squared. Now let's discuss ellipses. Basically, an ellipse is a squished circle, and it looks like this, our ellipse. So the center of the ellipse here, okay, from this point to this point is RA, which is the major radius, and B here is the minor radius, and the center is just HK, point HK. So center HK, A, this is our major radius. This is the length from the center to the edge of a circle, as well as B, the shorter one, which is our minor radius, the length from center to top bottom of the circle. So the standard equation for an ellipse is just x minus h squared plus y minus k squared. Now, x minus h squared over a squared plus y minus k squared over b squared equals 1. And then we have to remember this formula here: c squared equals a squared minus b squared. So we need c when we determine our focus, or our foci, for the ellipse. Okay, say for example, we're given here this problem: x plus 4 squared over 25 plus y minus 5 squared over 4 equals 1. So 25 here is our a squared, and then 4 here is our b squared. Because 25 is larger than 4, therefore it is understood that 25 here is our a squared. And the center here okay, is just equal to -4, +5, -4, 5. Our a, of course, is this just the square root of 25, which is 5. And then our b is just equal to the square root of 4, which is 2. Now, let's discuss more formulas for ellipses. Okay, so for vertical major axis, okay, it's right here, vertical major axis. Okay, let's divide this, split this in 2. And then this one. Okay, and the other one is horizontal major axis. Okay, so the equation for the vertical major axis for an ellipse is just x minus h squared over b squared plus y minus k squared over a squared equals 1. And then for the horizontal, that is x minus h squared over a squared plus y minus k squared over b squared equals 1. So you just have to familiarize this. Have you noticed that the major and minor axes are interchanged? Okay, so the center, they're just the same. Center is just hk as well as here. Then for the vertices, okay, vertices for the vertical major axis, that is h k plus minus a, and then here it's h plus minus a k. And then for the foci, that is h k plus minus c, and then here is h plus minus c k. So the major axis equation here, they're just the same. 2a, this is the length of the major axis, and then 2b for the minor. 2b, 2a, 2b. Okay, and then the eccentricity of an ellipse, you can use this formula, E equals c over a. So to find c, to solve for c, you can use this equation, a equals b squared plus c squared, or just c squared equals a squared minus b squared. And now let's discuss parabolas. Okay, the standard equation for parabolas, let me draw the parabola first. Okay, the parabola can look like this, can open downwards or upwards, can also open to the right, and can open to the left. So this one is our vertex, as well as this. Okay, it can be the lowest point or the highest point. So the standard equation for parabolas, if it opens up and down, the formula is x minus h squared equals 4p times y minus k. So this one is for if our parabola opens up or down. Okay, so if P is greater than 0, this one, actually P here is the distance from the vertex to the focus. So the focus here. We will discuss the rest of the formulas after this. So if P is greater than 0, then it opens up. If P is less than 0, it opens down. And then for those parabolas that open right and left, so opens right or left, so our formula is just y minus k squared equals 4p x minus h. You just have to familiarize yourself with all of these formulas. So if p is greater than 0, then it opens, the parabola opens to the right. If p is less than 0, then it opens to the left. And now let's discuss the other formulas for the parabolas. Okay, so we have vertical axis and horizontal. Like this. Okay, for vertical axis and then horizontal. Okay, the equation for vertical axis, that is x minus h squared, which I previously discussed just a while ago, equals 4p times y minus k, and for the horizontal, that is y minus k squared equals 4p times x minus h. And the axis of symmetry here, for the vertical axis, the axis of symmetry is just x equals h. Then here y equals k. And for the vertex here is hk. It's the same as here. And then for our focus, okay, for the vertical axis, the focus is just h k plus p. And then for the horizontal, that is h plus p k. And then the directrix for the vertical axis, that is y equals k minus p. And then for the horizontal axis, that is x equals h minus p. Okay, I would discuss the direction of opening. Direction of opening. Okay, so if p is greater than 0 for vertical axis, then the parabola opens upwards. If p is less than 0, then it opens downwards. Then for the horizontal axis, if p is greater than 0, then it opens to the right. And when p is less than 0, then it opens to the left. Now let's discuss hyperbolas. So the hyperbolas look like two parabolas back to back with center hk. So it looks like this. Okay. Okay. So that's our hyperbola, and the center is here, hk, or it can look like this. This is left, opens left and right, and this one opens up and down. So this is our center, hk. So the standard equations for hyperbolas, for this one, the equation for this is x minus h squared over a squared minus y minus k squared over b squared equals 1. And for this one, that is y minus k squared over a squared minus x minus h squared over b squared equals 1. Now let's discuss more hyperbola formulas. Let me give an example of a hyperbola equation. Let's say we're given here x plus 4 squared over 25 minus y minus 5 squared over 4 equals 1. The center here is just negative 4, 5, and this one opens left and right. Okay. Now let's discuss more formulas for hyperbolas. Okay, for vertical transverse axis and horizontal transverse axis. So this is, say this is our vertical, for our vertical transverse axis, and this one is for horizontal transverse axis. Okay, the equation for the vertical is just y minus k squared over a squared minus x minus h squared over b squared equals 1. And then for the horizontal, that is x minus h squared over a squared minus y minus k squared over b squared equals 1. And for the center, they're just the same, that is point hk, as well as the horizontal transverse axis. And then for the vertices, we have 2 vertices. So for the vertical transverse axis, that is hk plus minus a. And then for the horizontal, that is h plus minus a k. Then for the foci, that is h k plus minus c. And then for the horizontal transverse axis, that is h plus minus ck. And then we have to get our asymptote. So the equation for the asymptote, that is y equals k plus minus a over b x minus h for the vertical, and for the horizontal, that is y equals k plus b plus minus b over a times x minus h. And then we can use this equation, c squared equals a squared plus b squared, to solve for c. So you can find your focus, your foci. Okay, and now like you'll be ready to solve or write equations of any conic sections by using all of these formulas. And there is another technique on how to classify conic sections. Okay, if you're given this equation ax squared cy squared in this form plus dx plus ey plus f equals 0, we can determine whether the conic section is a circle, parabola, ellipse, or hyperbola. Okay, for circles, a here, this one, is just equal to c. And then for parabolas, a times c here, okay, the coefficients is just equal to 0. So both of them are not equal to 0. But when you multiply them, they should equal to 0. And then for ellipses, the product of A and C should be greater than 0. And for hyperbolas, the product of A and C should be less than 0. Okay, say for example, we're given this equation.